Hello, thanks for the introduction. And this is Angry Birds of JavaScript. I know it's a funny name, but hopefully it'll make more sense here in a minute. I'm Elijah Manor, and you can find me on Twitter at Elijah Manor as well. A little introduction, I wanted to mention who I am not. I am not this handsome gentleman right here. I actually got confused at a conference once and was introduced as Elijah Wood. So I am not in the Lord of the Rings. I am not Frodo. Anyway, I am Elijah Manor. I'm a Christian. I have a family, and I work. I actually don't work at Dependency anymore. I started my own business, Manorism Incorporated, and I'm essentially focusing on training as a Pluralsight Author and hopefully other trainings. I focus on front-end development like JavaScript and jQuery, HTML5 type things. And you can catch me on my blog or email me or catch me on Twitter. And if you want to see any of the courses I've done, you can hit bit.ly/etm-ps. I've done one course on mocking and prototyping apps, and more things are to come. So a little history. You might be wondering why the birds are so angry, because that's the title of the course, right? Well, they weren't always angry. They actually started out sad, and you might be wondering, why are the birds sad? And, well, they were sad because they're web developers. Well, actually, that's not the full story. They were actually poor web developers. They were copying and pasting code from the internet and just slapping things together and not really following any patterns or any guidelines, and just kind of flying by the seat of their pants. But eventually, they started to get happy, which is great. So they're still not angry, but they're happy. Their ancestors taught them some of the patterns that have been around forever, for a very long time in development, and they're starting to use some nice techniques and tools, and they're pretty happy. But eventually, the pigs, which if you've played the game, came, and in this case, they stole all their good front-end architecture patterns and tools. And so that's why they became angry. And so what they did is they basically picked some superhero birds to go and fight back the pigs and really regain the architecture that they lost. So that's the story, silly as it is. But what we're going to do is we're going to take, if you've ever played the game before, each bird has some kind of a strength or power. And so what we're going to do is we're going to take that power and somehow correspond it to some technique or tool or design pattern in JavaScript just to make it interesting. So let's meet our warrior birds. So here are the birds that are going to, they're angry because they're going to get things back. So we're going to first start with the red bird. And if you've ever played the game, the red bird's the most, it doesn't have a lot of strength. It's just pretty standard, nothing too special about it. So what we're going to do is talk about something that isn't really flashy in JavaScript, but it's something that you need to know. And it's really how to provide some encapsulation, some privacy concerns, just to really protect your code against anything else that's global. And so it's basically the building block of all privacy. And so what used to happen is the birds, when they were sad, they would have code and they would be accidentally overriding their own code, or they'd pull in third-party libraries and they'd be overriding their code. And it was just a mess. I mean, JavaScript's a dynamic language that's loosely typed, and so you could easily overwrite yourself without even realizing it. So before we talk about how to protect from this, let's talk about different ways objects can become global. And this is hopefully a review for some of you, but there might be some things that fill in the gaps on some of your knowledge. So here we're declaring two variables. One is type, which is a string of red, and another one's a function that we're going to store in the attack variable. And so what we could do is we access both of these off the window. So if something's off the window in the browser, it means it's global. Pretty much anyone can access it. So we could say window.type, and window.attack would be the function. We could invoke it if we want, but essentially they're both global things. There shouldn't be anything new to you. It's just the way things work. The second way something can be global is oftentimes by accident, and you'll often see this in people's code when they don't intend to do it. And here what we're doing is we still have the type variable with the red string, but inside of our function attack, we have, we're actually assigning type and appending bird and assigning it to some new variable type of bird. And you notice we're not putting a var here, so we're not actually declaring the variable. So what JavaScript does, it's trying to be nice to us. It says, oh, you haven't declared that, so what I'm going to do is I'm going to make a new variable type of bird, and I'm actually going to make it global. Even though you didn't ask me and you thought it would be local to this function, I'm actually going to hoist it onto the window. And so here we could actually notice that type of bird is off the window, meaning that it's global. And technically, I actually have to execute the attack function before it creates that, but essentially now we have 3 global variables. And that's usually by accident again. And kind of the third way of having a global is to explicitly say I want something global, even if I'm not necessarily in the global namespace. So here, for example, again in our attack function, we have the type of bird, which accidentally makes it global. But then here we're explicitly saying, hey, I want a new global variable. Even though I'm nested inside a function, I want to make a new global message and stick it out the window. So now we have 4 things that are global at this point. And that's probably on purpose because they actually said window there. So now it gets us to why are these a problem? And I've already kind of mentioned it. The first thing is there could be conflicts in your own code where you're overriding maybe some function that a friend of yours wrote, a colleague on your team. An argument against this is, well, we have a pretty rigid check-in process and we know what's going on and, we don't do that type of thing. Well, if that's the case, then there could be conflicts with third-party libraries that you're pulling in, such as jQuery or Backbone or other libraries. Now, the argument against that is like, well, our managers or tech leads vet those libraries pretty well, and we're pretty sure that we're not conflicting with things that jQuery might have, because they're pretty good citizens and they know what they're doing. Well, that's great and all, but the third thing it's hard to argue with is you're competing against extensions that are in people's browser. So a user coming to your website, if you're anything like me, I have like 50 extensions in Chrome, and each of those are running JavaScript and HTML and have CSS. And your website's actually competing against code that's running for that extension. And and that might seem a little silly, but there's a tool that I use pretty regularly, and it broke one day, and I was like, what's going on with that? So I contacted the developer. I knew him, and it turns out that he had me running all these tools in the dev tools, figuring out what's going on, and it turned out that some extension I had was conflicting with his website. So I had to eventually disable all my plugins and enable them one by one to figure out the culprit, and then I had to contact that developer. Eventually it worked out, but it was just kind of a mess. And so you don't want your code, enterprise-level application, to run into those problems. So you need to protect yourself somehow. The easiest way to protect yourself is to just put all your functionality inside of some other object. It's the easiest thing to do. It's a little cumbersome, but it's at least one way to protect yourself. So in this case, the type and attack, we're just shoving them inside another object called a bird. And so now we only have one thing exposed, which is the bird. And if we want to access the things inside of it, we just say bird.type or bird.attack. So it's just nothing really magic about it. We're just kind of moving our stuff around. Another way to protect ourselves, and this is more common, you'll probably see this quite a bit, is to use an IIFE. The long expression is an immediately invoked function expression. It sounds kind of crazy, but essentially it's just a function that has no name, and then you immediately invoke it by using the parentheses right here. And then you have to wrap the whole thing, because if you don't, the JavaScript parser kind of blows up and doesn't like it, so you have to wrap it in another set of curly braces. But what this gets you is anything inside of this crazy syntax becomes self-contained within that scope. So if you accidentally leak memory or whatever, it won't actually get outside the function. It's all contained inside that middle piece, which is great. So you see lots of libraries use this technique just to make sure nothing's going on and exposing itself to the window. Another name that this used to be called, which you might have been familiar with, is self-executing anonymous function. But really these days people call it an IIFE, which is just IIFE. So you could use this pattern and actually return something. So we're still using this pattern, this crazy-looking syntax. You'll get used to it after a while. So eventually I'm returning something. We'll talk about the code inside of here, but eventually I'm returning and I'll get a bird as a result. And so this bird will now have the ability to have private and public parts. And so the way you define that is inside of this IIFE, you'll define all your public and private things. Anything that you return at the very end will be what is exposed as public. So we have all this code. We have the fact that we have type and a power of a power of IIFE and an attack function. And you'll notice in the return, I'm returning type and attack. I'm not returning power. So the fact that I'm not returning power means that it will be private. And the end result, if a bird tried to access power down here, it won't actually be able to access the fact that it was a string that said IIFE. Now, things within the closure can't access the public and private parts, but the part that we're exposing won't be able to do that. So this technique is called the revealing module pattern. It's been around for quite a while, and you've probably seen it, and if you haven't, then here it is. Another way to use the IIFE is instead of returning something, we're going to pass something in. And so this is another common technique that you'll see in libraries. And actually this is a common technique across libraries that have different components that you all want to work together. It looks a little weird, but we're actually passing in an argument down here at the bottom. And what we're saying is we're first asking, hey, does the bird exist off the global namespace? And if the answer is no, which it doesn't, then we'll go to the second part of the OR statement and we'll resolve the new object right here. And then we'll assign that new object back to the bird. So now we're assigning a new object to the global bird. And then what eventually happens, that gets passed into our IIFE as the bird up at the top. Then, after all that, because that's a little confusing and involved, now pretty much anything that we attach onto the bird, like bird.type, bird.attack, those will be public things. And things that we don't add to the bird, like power, for example, will be private. Now, at first glance, this doesn't really seem like it gains us much from the previous technique, but what it does give us is we could repeat this pattern. So if we did this whole piece of code again, what would happen is in the argument, window.bird will resolve to a truthy expression because now it does exist. And so it will just reassign itself back to the bird, which is a little redundant, but that's what happens. And then we'll pass the existing bird into our IIFE, and then we could kind of build up behavior and functionality across our library into possibly different components. And each of these patterns can have public and private parts, so it's kind of nice. All right, so this might not show up very well because it's streaming, but I used a physics engine, JavaScript physics engine, to make a little game. And you probably aren't seeing this at all. But I have to actually kill these little pigs before we can proceed to the next level. There we go. There's really no reason why I did that, just because it was fun. And actually my kids, for one of the first times, saw me doing it, and they're like, whoa, that's pretty cool, Dad, what you do at work. So anyway, it's kind of funny. So normally I just say I make programs, which is not very exciting. So now we're going to the Bluebird. If you've ever played the game, the Bluebird, so it does have some kind of unique property. It's not just the red bird that's just normal. The Bluebird, when you launch it, if you touch the Bluebird, it splits into little pieces, like 3 other teeny birds. And so what we're going to talk about in this particular bird and correlate to JavaScript is the idea of events and messages. And there are actually several different techniques of using messages, and we'll talk about the pros and cons of each, which one you should use when, and some nice libraries to help you do that. So the thing that was actually stolen by the pigs is a long time ago, the birds, especially the Bluebird, would tightly couple all of his components in his library. So, he did create the different components, but they all had tight references to each other. So if you ever wanted to reuse one of those components, let's say you had a shopping cart and a navigation system and all these other ones, it's great to have those separate components, but they were directly calling each other. And so if you wanted to actually reuse one, you had to kind of bring all the others with it, and that's just kind of cumbersome. And so by using events or messages, you can actually split those up so they don't have direct references and your code's in a better place. So what we're going to do is we're going to run this little sample application, Star Trek. It's a little app that goes out and gets some movie information. So I type in Star Trek, it pulls back some movies. When I type in Star Trek and say search, it adds it to the example. It's like a history. So I could say Doctor Who in here. It will, if I search, it'll add it to the example history and eventually get the movies. And then I can come back and click one of these, and it'll update the system and pull back the movies. So nothing really crazy here. But what we're going to do is, but just by looking at it, it's like, oh, that's kind of cool. But behind the covers, the code is a mess. So let's take a look at the code. It's extremely tightly coupled. It's usually what a developer, when they're first coming to jQuery, will end up writing because it's such an easy thing to pick up. jQuery, the language, or the library, the language is JavaScript. But it's such an easy thing to pick up that you just kind of slowly add things, and then it keeps getting bigger and messier. I don't expect you to understand every line in here, but essentially we have mostly one big click event handler when we click on the button, and then it's doing a bunch of stuff right here, and then eventually it has to call AJAX, and then inside the success is the rest of our code. It's just one tightly coupled mess after another. We have DOM manipulation mixed with getting data from the server, mixed with massaging the data. It's just extremely coupled. So if your boss came along and there was a bug, you'd be like, where exactly is the problem? I don't really know. And it would be really hard to separate these out into different files or components. So let's take a look at how we can make that a little bit better. Now, obviously, if we use the MVC framework, that would definitely make it better, but even those are using the patterns that we're going to talk about. So the first thing we're going to talk about are observer events. And so this is one of the Gang of Four design patterns, been around forever, and it's a fancy term, and you've probably been using it already. It has a name for it. They're called observer events. But essentially, these are adding functionality like an event handler directly to some other element. So something that you might be familiar with is, I'll first look at the jQuery. We're grabbing some element on the page, like a bird element, and then we'll directly call click, which is one of the event handler wrappers, which we're attaching the callback directly to that element. We could have called bind, which essentially is just attaching a function directly to that DOM element. Same thing with on. There's many ways to do this in jQuery, just because some of the history there. But essentially, they're all attaching functionality directly to something else. You could write it straight up in the JavaScript and DOM by just saying get element by ID and calling add event element. But essentially, when we come down here and we trigger the click event using jQuery, it will trigger this event, and then the functionality is attached directly to that element, so it just knows what to trigger. So that's an example of an observer event. Now, there's another type of event called a mediated event. There are other terms that you could call this as well, but it's essentially there's some kind of a third-party individual that's keeping track of publishing and subscribing messages. There's not a direct correlation between the functionality and the thing that you're wanting to track. And so one of my favorite libraries to do this is called Postal. A friend of mine, Jim Cowart, made it. He's really smart. He's if and else on Twitter. You should follow him. He has a lot of other really cool projects as well. But essentially what you do here is you say Postal, I want a new channel. So you can have different channels of messages, which is actually kind of cool. I'm just grabbing the default one. And then I can subscribe or publish using that channel. So, for example, I want to listen when any bird has been launched, and I want to listen for when any bird has been reset. And then it supports some wildcard type stuff, even more than just what I'm showing. So anytime a bird dot something happens, I want to know. So the way you use this is I could say channel, publish, a bird has been launched, and I could pass some data that the angle was 45 degrees. So essentially what would happen is obviously bird.launch would fire because I'm subscribed to that, but also the bird.star will fire because it's a wildcard. It matches. And so if I called bird reset, which I do down here, then not only the bird reset one gets invoked, but also the bird.star. There's lots more functionality to this library, but essentially we're dealing with some third party, which is our channel, to handle the communication between the components. The third type of message is kind of a hybrid approach between the two. Oftentimes it looks like it's a mediated event, but under the covers there's like a direct correlation, and it's more like an observer event. It's just kind of hidden from you. An example of this is if you were to use jQuery to handle some of these events, it might look like it's a mediated event. For example, like here I'm grabbing the pigs, and I'm listening for events or triggering events. Actually, here I'm doing delegated. It doesn't really matter, but essentially I'm using jQuery to handle these events. In jQuery, you can make up your own event type. So there's native ones like click and mouse enter and things like that, but I can make my own called impact. I can say, hey, I'm going to make up a new event called impact event. And eventually I'm going to grab the first pig and say trigger an impact event. So obviously, since I'm listening for the impact event, this code will be executed by jQuery, which makes sense. Some things in here, it'll pass the event that happened. I can actually grab the target of what, what was triggered. I can actually grab the delegate target of where I stored that information. So I actually stored that information on the pigs up here. So that's interesting. But what I could do, if I know enough of the undercovers of jQuery, I could actually poke around and look for some other information that's stored inside the delegate target. So I'm looking inside of its hidden events, and I'm poking around, and actually I found a handle to some other event that I shouldn't have been calling because it was a secret event. And I could actually invoke it. And so I could call I'm hiding no telling one, and I didn't really mean to. And so it's really kind of a hybrid approach, and really no one would probably ever do this. But I'm just kind of showing you that it looks like a hybrid, it looks like a mediated event, but under the covers there's some tight correlation going on. So I've just told you a lot of information, and you might be wondering, okay, Elijah, that's great. You just showed me 3 things, but when should I use what and how? So Jim wrote an article, and he had a great quote that I liked. And basically it was to use the observer events, which are, attaching event handlers directly to elements. That technique, use that inside a component. So if you wrote a component like a shopping cart, use that technique internally inside that component. But if you want different components to talk to each other, like a navigation component and a shopping cart, that's where you use a mediated event, like Postal, for example, and allow Postal to communicate between the two. So that way there's not a direct correlation, which is kind of nice. All right, so I used this technique to try to split out the code we had before a little bit. Now, you can make it probably even better if you used Backbone or Angular or Ember or one of those tools. But just straight up events, we could totally change this code. So here, when someone clicks on the button, all I'm doing is I'm just publishing the fact that the search term was changed. And I go ahead and pass the value that was clicked on. And then you'll notice I have 2 pieces of code that are both listening to the fact that the search term has changed. One piece of code, when the search terms change, kicks off some kind of a function to actually go out to Netflix and get the titles. And the other piece of code just handles adding the fact that you were searching for something new in that history. You remember that example piece where, it's up at Doctor Who, it kind of remembers it and makes a link. So one actually gets some data, and then the other one actually manipulates the DOM. So we've kind of separated the two, so we're not doing a bunch of code just when something changes. You'll notice when I get the data back from Netflix, then I'm publishing that the Netflix titles is updated, and I'll pass the information. There's another piece of code that just listens that the titles have been updated, and it handles just the DOM manipulation, which is kind of nice. Now, I'd probably like to clean this up a little bit further and maybe use some kind of templating engine, but we'll talk about that with another bird. Anyway, there's more code, but essentially I could have stuck a lot of these pieces in different files or different components, and it would have been a little bit easier to maintain. Now, again, you'd probably write this even better and use some MVC framework. Okay, so this brings us to Yellowbird. Yellowbird, if you've ever played the game, again, you launch Yellowbird, and eventually you click it, and then it goes, on steroids and goes really fast or something like that. So we're going to talk about require.js, and the point of require.js isn't necessarily speed. It's more about modularity, but as a side effect, it actually can make things faster, which is nice. And so let's talk about this. So the thing that was stolen from the birds is the fact that they used to always, in their applications more and more over time, you start adding lots of script libraries and plugins and things to your page. And so eventually you might have 20 to 30 script tags on any one HTML page. Now, eventually, hopefully, you're minifying and combining these. But in design time, you're sticking all these files, and it can get really confusing which order to put them in, especially if a new person's coming onto your project and they've never seen the code before. It could be a little daunting. But Require.js comes in. Its main purpose is to help modularize your code, load them asynchronously, manage the dependencies, and hopefully eventually optimize it, as we'll see. So if we go back to the Bluebird, and I told you about Postal that my friend Jim made, you might go back home, and well, you might be home right now, but you might pull down Postal and start playing with it. So let's say you pull in jQuery just because you think you might use it. You pull down Postal because I told you about how cool it was, and then you pull in underscore because pretty much I always pull in underscore in most of my projects. It's a nice helper library. So you kick off a new channel, you put a subscribe and a publish, but all of a sudden, bam, you get this big error in the middle of your face, and you're like, and then you start complaining and blaming the author, Jim, for making buggy code, and you blame me for recommending it, and then you just get in this tizzy, and then all of a sudden you start realizing, oh wait, it can't call the each method. Like, wait a second, and then you start thinking like, well, undefined has an each method. Maybe for some reason it needs underscore. And really, behind the scenes, what should have happened is Postal actually depends on underscore to be there before it runs. And so we just had them in out of order. And this might seem like a trivial example, but imagine we had 20 or 30 scripts in here. It could be non-trivial to mess up the order of certain components. So what we're going to do is we're going to pull in Require.js and see if it can help us out a little bit with this problem, because this is a pretty common problem, especially on large projects. So there's two main pieces to Require.js. We need to define a module, and then we need to actually require that we want the module. And so what we're going to do is we're first going to require this module, and we just say define. And the name of the module, it'll default to whatever the name of the file is. So the file name is my first module, so that will end up being the name of the module. So first you pass in an array, and this will define to the module the things that you need to run. So these are the dependencies. So for this module to run, we actually need underscore and jQuery. So that's what we're saying. So what Require.js will do is it'll go out and make sure it pulls both underscore and jQuery and that they're executed before it will actually execute whatever is inside of your module, which is nice. And will actually give us handles to the libraries that we requested. So the underscore was the first parameter, so it'll put the underscore library inside of this parameter. And we asked jQuery to be included, so it'll actually put jQuery in the $sign. So within your code, you're guaranteed that if you use the underscore and $sign, they will have already been loaded and they'll be available to you however you might need it, which is kind of nice. So eventually, when you're to the point where you want to use your module that you created, you just say require, and then you tell it the things that you want to require. So in this case, we're just saying, I want that module I just created, the my first module. And you can give it an array. So what will happen, before it executes this function, it will first pull my module, but then my module said it needed underscore and jQuery, so it makes sure and goes to get those first, and then it will run my module, and then eventually it will give me an instance of my module and then allow me to do whatever code that I want to do inside of it. So it handles all that crazy stuff for me. It knows what order it needs to be done in, and it knows exactly when to pull the files, etc. So to change our markup, all we have to do is basically remove all the other scripts that we had, because we had 3 scripts. And we just have one script, which basically we're telling it where to find Require.js, and we're telling it where to start. So basically look in this file for all the information that you need, to run the rest of the stuff. So let's look in that file. This is our main.js file. There's a couple things we have to provide. You'll usually find a require config in here. And we need to give a couple of helpful information to require.js, such as some path information. So when I say I want jQuery, where is that file exactly? And so you give it the path. When I say I want it underscore, where do you find that? And when I say I want it postal, where do you get that? Then there's something interesting that comes along. There's this shim. So in order for me to use these modules, they at some point had to declare that they were a module. The interesting thing is if you actually pull up the source code of jQuery and look at the very bottom of jQuery, like the real version, it actually defines itself as a module, which is pretty cool. Postal, at the very bottom of Postal, it will actually define itself as a module. And it actually says it needs underscore to run. But unfortunately, underscore does not say that it's a module anyway. It actually used to, but they took it out. And I don't know all the political reasons why they took it out, but it's not there. So since underscore doesn't say that it's a module, we actually have to shim it. And we're basically going to say we're going to treat it as a module. And so here we're defining that underscore, we're shimming it to be in a module, and we know that at the end of the day, underscore sticks all its functionality on the underscore, so I want to export the underscore as a return of that fictitious module that we're creating. So now we've wired up all our things. And so if you use any other scripts that don't define themselves as modules, you would shim them as well. So at the end of the day, all we have to do is say, I want to require that we want postal. And since postal behind the scenes says it needs underscore, it will have pulled underscore as well. And then now we can run our code as we did before, and then everything will work because require.js made sure underscore was loaded first, and now we have all our dependencies in the right order, and it just works. So since we've gone to all the effort of defining our dependencies and what needs what and when, wouldn't it be nice if we could optimize and let some system just figure out which order and combine and minify those in the right order? And yes, you can. So there's a project called RJS, which require.js comes with. And you just give it some special information about where the application is stored, where you want to actually store the output, where to start, which is our config file, and it will actually minify your CSS as well. So you tell it what type, how rigid should it optimize your CSS. And then you have to repeat some of the path information, which is a little cumbersome because we already did that. But there are some ways to get around that, which we won't talk about right now. But all you do is you kick off the RJS and you tell it which build file to use, and then it starts going through your application, finding all the modules, figures out which order to put them in because it knows, and then eventually, and then it'll also optimize your CSS, and then at the end of the day, it'll give you a nice output of main.js, which is the combined minified version. RJS is really flexible. I just showed you a real straightforward approach, but you can do lots of more advanced things as well. All right, so which brings us to the Whitebird. So the Whitebird's a little less code intensive. It's more of like a conceptual type thing. So if this has gotten a little heady for you, then this will slow down just a little bit for this particular bird. So the Whitebird is you launch it, you eventually touch it, and then it spits down this egg, which just explodes on people. It's just really kind of weird, and then the egg just flies out. This bird I represented to code quality techniques, and so sometimes it's a little different. People come to your project with different experiences, and each one has their own standards, and they code a certain way that they think is right. But really, in the end, that becomes really hard on your team because everyone's struggling and just not having a good time. So this bird that plops down an egg is basically plopping down some kind of standard that you kind of need to abide by. And it's sometimes kind of painful, but in the end, the goal is to kill or to get rid of the pigs, right, and to get back to the architecture. So there are some good things that come from it. Hopefully by using standards, your developers can make sense of other people's code more quickly because it seems a little more cohesive. Merges into your repository aren't as painful because if you're using Git or GitHub, if everyone decides to reformat their code, to their own liking, then, every line has changed, which is not true, but that's what it looks like. Hopefully over time, defects will be reduced because, and it's not because you have this magic pill that a standard fixes everything, but it encourages you to develop in a certain way, which has been proven over time, and that's arguable by some people, but eventually that might actually reduce some defects. And eventually your code base will feel more unified. It won't be like, oh, Joe wrote that because, he does it that way. And, Charlie wrote that and Susan wrote that piece. It feels a little more cohesive, which is good. And hopefully disagreements about who's right will lessen. However, that still happens. And really your coding standard could evolve over time. It doesn't have to be one thing all the time. Because we learn every minute. I'm learning all the time. Some things that I did last month I don't necessarily do today. So which standard should you follow? That's a good question. There are several good ones out there. Douglas Crockford has one that's been around for quite a long time, so you might look at that one. One that I really like is Rick Waldron's Idiomatic.js. He's a really smart guy, and he had a bunch of other really smart individuals, men and women, help with this recommendation, and I encourage you to look at that. It's on GitHub, Idiomatic.js. jQuery has a pretty succinct style guide. It's not as long as the Idiomatic, but it has some nice points in it. The company I used to work for, Pinto, unofficially used this one for their developers, and it worked out pretty well. And Google has its own, too, which it's good to look at. Now, you don't have to use any of those. I just encourage you to use something, and hopefully your developers could follow it and gain something from it. Now, whatever you use, I encourage you to actually use some tooling to help you abide by that. One that I like is JSHint. It's a fork of JSLint. JSHint has a lot of more options you could turn on and off and some more features that JSLint does not have. And so these are things that have been around forever, like encouraging you to use the triple equals instead of the double so you don't coerce your types, making sure you're not using variables that weren't defined, or if you did define variables that you're actually using them, things like that. But some of the things I really like are some of the recent additions that have been added, such as checking for a max complexity of a function. This uses the cyclomatic complexity algorithm, which essentially just figures out how actually complex is a particular piece of code. And there's a number that it gives out, but you could basically pick some number like 20 or 15 or 10 and say if it gets more complex than that, maybe we should reconsider refactoring it to make it not so complex. And there's some really complex rules about how it figures that out, but it's a nice gauge. Another thing is max statements. You could say, hey, if a function is over 20 lines of code, maybe we should think about splitting it out. So it's a good gauge. It doesn't necessarily have to mean you have to, but it could encourage you to make your code base better. Max parameters, you can say, hey, I don't want any function with more than 5 parameters. Maybe you should reconsider passing in an object with those things inside of the object instead. And again, that's arbitrary. You can just choose a number for what's good for your team. Max depth is a good one because if you have 10 nested if statements, that can be really hard to understand. And really, if it's that big, you probably should split them out anyway. And so you could pick some number for max depth. And there's max of length, which is probably not as important, but if you don't want your lines of code to be more than 80 or 120 characters long, you can provide that. So I put together this silly little piece of code that is slightly nested, kind of long, has a lot of arguments, and then I went ahead and put some JSHint information at the top. And you could pull these out into a global file. You don't actually have to put it on each individual file. But I'm going to run it through the JSHint system. And sure enough, we'll get all these errors like we have too many parameters, we're nested too deeply, we're too long, we have too many statements, and our function's too complex. Like, it had a lot of if statements and loops, and it was too complex. You should simplify it. Now, obviously, your numbers might be bigger than this, but this just gives you an idea. Now, I ran this on the website, which you probably won't want to be doing, but you can integrate this into many IDEs as well, like Visual Studio or Sublime Text or whatever, Vim or whatever you use. Another tool that's really nice is called Plato. And this gives you a more visual representation of what's going on in your application, and it actually works over time, which is nice. So Plato has an example report where this one was ran on the jQuery project itself, and every time you run it, it gives stats. And so the cool thing, over time, jQuery has been getting smaller, which is a good sign. There's still a lot of lines of code, but it's getting smaller. The complexity is getting a little bit higher, but not too much, so that's a good sign. You can't see all these lines down here, but each file is separated into different modules. And you can click into one and drill down. So we drill down into the events JavaScript file. And here's like some circle charts about how complex each function within that file is. And so this really large section is the trigger function inside of the events JavaScript file. And so it's the most complex of all of them. So you can easily click that, drill down, and find out why it thinks there's problems. Same thing, there's a line of code circle here, and you can actually, I think the add function was the longest. You can actually look in there and see maybe, if you need to refactor it or something like that. All right, so let's proceed to the green bird. The green bird is like a boomerang bird, so you launch it. Eventually you click it, and then it kind of swoops back and returns kind of like a boomerang does. So the thing that I'm going to correlate here is the fact that sometimes it's nice to test or to prototype your app and simulate data that comes back from the server. So you're not really communicating to the server, you're kind of boomeranging some sample data back, just so you can kind of see if things work or if it's behaving like it's supposed to. So what I like to talk about is the symbiotic relationship between the water buffalo and the bird. So the birds are the front-end developers. The water buffalo is the back-end developers. And they're both important, but usually the way it works out is the buffalo write all the code, and they've been running unit tests forever. They make sure it's really solid. Eventually give the bird the work, and now all the pressure's on the bird to integrate and make a nice, fancy, dynamic website. And so historically, it used to be really frustrating for the bird because they'd be scrambling, and the water buffalo would be, by the pond soaking up the rays and, drinking it up. And he wouldn't have much work to do. He had a lot of work at the beginning, but not at the end. And so the bird was the opposite. He was kind of tweeting around and then eventually, had a lot to do. So in the past several years, some nice libraries have come out, which enables both the buffalo and the birds to work independently and productively because we're mocking out data. So as long as you have some kind of a common contract of what data is going to be passed back and forth, then we can actually rock on and be very productive independently. So that's cool. So we're going to look at a simple Twitter app. We're actually not going to look at the code. We're just going to look at the results. Twitter's a bird, so it fits really nicely with our Angry Birds thing. So here's a simple Twitter app. We're hitting the deprecated API as of yesterday, so this doesn't work anymore, which is good that we're mocking the data. And they're eventually getting data back, adding it to the DOM, yada, yada. It's not really important in the code right here. But the data that comes back, if now you're using the 1.1 version of the API that's authenticated, it looks much like this, where you have a really big object of what was tweeted, the ID, if it was favorited or not, how many times it was tweeted, where you tweeted it from, if it was from the phone, etc. Just a bunch of information. But if you want to actually unit test this or prototype the website with, maybe Twitter's down or they just deprecated the API or something, wouldn't it be nice if you could actually test your code without it working? So here's where we're going to introduce the mockjax library. And it's a way that we can mock jQuery AJAX requests easily. And so they don't actually make the request, but we can fake it out and make it seem like it did. It's really easy to use. You just say $mockjax, and then you pass it some object, much like the object that you might pass into $AJAX. You get up a URL, which is the URL you want to listen to. And so if any AJAX request or, GET or GetJSON or POST, any of those wrappers, if any of them try to hit this API or this URL, API jQuery or API Twitter.com, one yada, 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 with an asterisk, meaning that's a wildcard, then I want you to intercept that particular call. I want you to give a 750 millisecond latency. I want you to basically seem like it took a little bit of time. And I want you to, after that timeout, I want you to send back a hard-coded array of tweets. And so I have an array with a tweet with an index and when it was created, the test, if it's favorited, and the user was created. Now, a couple things to notice. One, our objects are a lot smaller because your app might not need all that extra additional information. It just might need a subset, which is kind of cool. So what eventually happens, if I call the same code, regardless if I'm hitting the real API or the fake one, I'll still get a response. And so in this case, I get this trimmed down version that it was favorited, retweeted, text, and et cetera. And so our app could still work. It thinks that it was hitting the back end, but it really wasn't. Unfortunately, this is ultra boring and super static. Anytime I'm mocking out data, I'm a very boring person. I'll have like test tweet 1, test tweet 2, test tweet 3, user 1, user 2, and that's not a really good way to exercise your system. It looks boring, but also you might not catch real usability things like, what if it's a longer piece of text and maybe it doesn't wrap correctly and things like that. So here's where we introduce another library called mock.json. And this is a way we can use a template of what we want our object to look like, and it will automatically generate a semi-random version of that object. So we're going to use them both together. We're still going to use mockjax here, but now we're going to call mock.json, and we're going to say we want to generate from a template, and then you pass it the special template to use to generate the data. It has some special syntax, but it's essentially just JSON that you pass it, but you give it a pipe here. So here we're telling it it's an array, but if we say a pipe and we say from 5 to 10, then what it will do is it will generate 5 to 10 versions of this object inside of that particular key. And so for each item it generates between 5 to 10, it will use the internal template inside the square brackets to define what each individual object looks like. So here on the ID, we're saying we want a number type because we said 0, and we want it to increment by 1. So we'll have the first tweet will be index of 0, the second tweet will be index of 1, etc., so forth. And then we want to create it at, and you'll notice in here we have these special keywords. And so anytime there's an ampersand, that means it's a special keyword. So time_HH will give us some kind of a value that matches a time. And then we have an ipsum lorem text or lorem ipsum text here. For a Boolean, since we said false, it means it's a Boolean type, and we want either a 0 or a 1, so it'll randomly pick if it's true or false. And then you can actually have nested objects here. So we're saying we want user, and for that particular item, we want the object to look like this. And it has a male first name, so it'll pick some first name that's a male, and then there's last name. The cool thing about this is we could make our own keys like this. So if we really didn't want ipsum lorem text, but we wanted text that kind of looked like a tweet, we can make our own version of the key and make it look like real data. At the end of the day, we get a random version between 5 and 10 tweets. So here's an example of one of them. Our date looks pretty good. You notice it randomized, so retweeted was true, favorite was false. The text is a little boring. We could have made our own keyword for that one to make it look a little bit better. But you notice Jose Martin was one of the random names, which sounds like a real name, and I'm sure someone actually has that name. So that's good. So now we can actually exercise our UI, and it could pull back however many tweets you want, and you don't have to manually code these things, which is really nice. All right, so the next bird is the orange one. And we're going to talk about templating with this bird. So this bird, it starts out small, and then you launch it, and you click in it, and then it gets really big. It expands out like a big pufferfish. And what we're going to talk about are templating engines for this piece. What was stolen was the fact that the birds were concatenating all of their strings to make markup. And so it was very cumbersome. It was kind of mixing their view logic with their actual code, and it was just kind of weird. And so an example of this might be that same app that we had before, the Twitter app. You notice in here I'm looping over all the tweets, and I'm concatenating a bunch of markup. So I have a bold here and a span there and icons, and I'm just munging all this markup together and eventually spitting it into the DOM. And I really don't like this code. It's usually, for me, it's a code smell. Some people might like it, but I prefer not to write that code. So that's why I use a templating engine. The two engines that we're going to look at are underscore and handlebars. So the first one, if you have underscore anyway, there's a templating engine inside of underscore, which is based off of John Resig's micro-templating library he wrote a long time ago. But there's essentially two steps of most templating libraries. One is the compile step, and then one is the version where once you have the compiled version, you pass in data. So underscore, you say underscore template. We want to grab some markup that will be our template, and then we want to compile it and give us a compiled version. And then eventually, once you have your compiled version of your template, then you just pass it data, and it makes sure everything works correctly. Now, before we proceed too far, we have to look at our template. So the way you usually do that is you define some script tag on your page, give it an ID to reference later, and then give it some weird type. It doesn't matter what type it is, as long as the browser doesn't understand it, you're fine, because it won't render it if it doesn't understand it. So text template works just fine because the browser doesn't know what that is. But inside, we put our markup that we want to build up. And you'll notice some special syntax like this less than %. It basically just means we want to stick some code inside of here. So we want to loop over our tweets that we passed in. For each tweet, we want to basically stick the information inside of the item. So we use a different syntax, the less than %equals, which means, basically interpolate whatever that value is. But something I don't like is right here. I'm doing quite a bit of logic right here. I'm using another library that parses dates to create like a relative time. And I'm doing quite a bit here, and I don't like that because templates are really hard to debug. Actually, it's very hard to debug. It's usually it works or it doesn't work. And so you don't want much logic in here. Even some people might argue having this each in here is too much, and there are other ways to handle that. But just for simplicity, we're leaving the each in. But what I don't like is actually parsing the date and then all that junk. So what we could do, and so the main point is, even though we can run any piece of code inside of a template, you probably shouldn't. With great power comes great responsibilities, so just try not to do that. So what we could have done if we used underscore, again, we're grabbing instance of that script tag by ID, grabbing the contents of the script, which is our template, and we're compiling it. But before we actually pass in our data of the compiled version, we could iterate over the values of the array, manipulate the date ahead of time to get the relative date, and then assign it back to itself. So we eventually have an array with nice dates. Now that we could do that, but I don't really like the fact that I have to do all that work. It does clean up our template, so now we just have to say tweet created that. But again, I don't like the fact that I had to do all that work up front. So let's take a look at another library. But before we do, let's talk about why underscore is good. It's good because you can pretty much stick any JavaScript in there. That's also one of the cons, by the way. It's very small, and you probably use it anyway, especially if you use Backbone. You could compile the templates, which is good for performance. And you can run it on the server, so if you use Node.js, it works just fine. Now the cons is pretty much you can run any arbitrary code. That's pretty much, it was a pro, but it's mostly a con to me. And I'll skip that. So the next library, which I prefer instead, is called Handlebars. The reason I like it is because you can't really put arbitrary code inside of your template. But you can register helper methods. So here I'm registering a helper called fromNow. And inside my helper, I'm defining parsing the date and actually calling fromNow, which gives me a relative date. I still have to compile it and still have to pass data into it, just like the previous version. But my template looks a lot cleaner. Now, it uses different syntax. It uses the curly braces, which is supposed to signify like a mustache, handlebar mustache. But you notice I can use the helper method called fromNow and just pass it the date. And it will internally know to call the function and parse it and call fromNow, which is really nice. So one of the other reasons I like Handlebars is because you can pre-compile your templates on the server. So I showed you there's always two parts to the template. You have to compile it, and then you pass data into the compiled version. Well, wouldn't it be nice if we could compile it before it even got to our browser? There's no real reason why we have to wait to our browser. So with Handlebars, you can actually do that compile process on the back end and then pass back the compiled version to the front end, which is pretty cool. So that reduces the amount of work that the front end has to do because it's already been done. And then the second benefit is there's a smaller version of Handlebars that doesn't know how to do compiling because we don't need to know how to compile because it's been done on the server. So now we have a smaller version of the library, which does less work. And so it's kind of like a win-win situation. It's almost as cool as Batman riding a rainbow unicorn alongside dolphins, which I think is pretty awesome. And especially if you're from Florida or anywhere with an ocean, that's even cooler because dolphins are cool. And So why is Handlebars cool? Well, it's a logic-less templating engine, meaning it encourages you to not put any logic in your template. You could pre-compile the templates, which, rainbows, unicorns. It supports helper methods, and you can also run it on the server. And it supports the concept of this, which we didn't really talk about much, but you can talk about that later. And it's a superset of Mustache, so if you already knew about Mustache templates, then you know about Handlebars. Now, the main con, I initially thought I was slower, but I ran some initial tests with comparing the two, and it wasn't really compelling. So I don't know. I couldn't think of any cons. I'm all pro about it. So now, if you're not sold, you might want to use a different engine. There's a nice template chooser by Miss Means, and it basically just asks you a bunch of questions about what you want in a templating engine. Like, do you want it to run on the client and server, or should it have logic? Can you precompile it and just answer yes or no or whatever? And it will filter down the options to give you what maybe you need for your particular project. Maybe it's not Handlebars, maybe it's not underscore, and that's fine. And there's actually some that aren't listed here that would be nice if it did, but it still might not change your mind, but it's a nice tool. This is the last main point, so if you want to stick with me, then that's good. The Big Brother bird is kind of the big daddy one. It's kind of like the red bird, but it's just a lot more powerful. Some people think JavaScript is a toy language. It's like a scripting tool, but it's much more than that. And you could use design patterns that have been around for a long time and use it in this language. We've already seen the observer pattern and the singleton pattern, sort of, with the object literal. But essentially, the pigs stole these nice known gang patterns that have been around, the Gang of Four patterns. I affectionately call them the Gang of Foul patterns. But the factory pattern is a way to create new objects without using the new keyword. So if you wanted to do something like this, and this is a little isn't as complex as it could have been, it's a little naive, but for example, we could create a bird with a factory method, and eventually we could say bird factory red, meaning I want a red bird, or bird factory blue, meaning I want a blue bird. And the trick here is you define that these constructors like this. Now I'm not doing anything inside the constructor, but assume I was, that there's a red bird and a blue bird. So when I say pass in the red string into the factory, it comes in as the type. And then what I do is I look to see if there's a bird of that particular type. So if it does exist, it should match up with one of the function constructors that I had below. And so bird red was a function down here, so that's a match. And so if it is a match, then I'll actually new up an instance of that bird type, and then eventually I'll return it from the factory. So this is kind of a naive approach, but it's using the fact that it's a very dynamic language. And once we type in, we can just kind of shove things around, which is kind of nice. A facade is actually, it's also a pattern, but if you've used jQuery at all, you've been using a facade because basically what it does is it gives a nice wrapper version around things that are very much not consistent. So adding events to a browser is not a very consistent type thing. The APIs are all over the place. And so, but jQuery kind of abstracts those from you. So it kind of does something like this, where it first to see if there's if add event lister is existed. If it does, then it uses it. If not, it checks to see if attach event exists, which older versions of IE use. And if it does that, then it will use attach event instead to wire up your events. So this is a type of facade. And again, jQuery uses it all over the place to support older browsers, especially the 1.9 branch of jQuery. An example of an adapter is a piece of code that I wrote back when I was at Dependency. If you've ever done WinJS promises with the new Windows 8 apps, writing JavaScript apps, there's something called WinJS, and they have their own idea of promises, which don't work well with jQuery's version of promises. And something I like is the $.win, which understands jQuery promises. So what I did is I wrote this little adapter, which basically it looks to see if it's a WinJS promise. If it is, then I automatically convert it to a jQuery deferred promise, and then so that I could use them interchangeably, which is kind of nice. Chaining is a very simple pattern to do. So jQuery supports chaining. You're probably used to that. Many other libraries, they call this the Fluent API, but it's really easy to support. So if I had a bird object in JavaScript, each function I would just return this. This would be an instance of the object itself. So I'm returning an instance of bird from each function, or from each method, which allows me to actually continue to call other methods off that object. So I could say bird.catapult.destroy, and I could keep calling more and more methods. But the main trick here is just say return this. If you've ever written a jQuery plugin, it's the same concept. At the very end, or at some point, you have to return the jQuery object so that it's chainable. There are many more patterns, which we don't have time to talk about, but here's some nice resources for you to continue learning. Some of them are free, like Learning JavaScript Design Patterns by Adi Osmani is free. JS Patterns is free. These are both online sources. The rest are books that you can pay for. They're very good. And the Douglas Crockford's version, there's a free 5-part video series on Yahoo that you can watch. And the last part we're just going to blow past it is basically automating all these pieces together. So I told you about JS Hint, I told you about Plato, I told you about pre-compiling your templates and running RJS to minify your code. But wouldn't it be nice if there was a tool to automate those things? And yes, there is. It's called Grunt. And there's all these plugins that you could use in Grunt to automate all these things. There's 2 main pieces to Grunt. One is just describing the name of your project and any dependencies that you need, like plugins. And then there's a Grunt file, which this is where you describe all the things that you need to do, which plugins you depend on. You can definitely look on the website on how to use it in particular, but it supports all these plugins and way more. Like if you have CoffeeScript and you want to auto-compile, or if you want to lint your CSS, or pre-compile your handlebars templates, or minify your images, or run unit tests automatically, or require JS, minify your code. You can do all these things, and you can actually set a watch so it does them automatically if any file has changed, which is pretty cool. And so it just does it behind the scenes. And you definitely uglify your code and generate docs. Tons more things. This is just maybe 0.5% of all the plugins that you could use. jQuery uses it, Modernizer uses it, Adobe uses it. Many well-known projects use Grunt, and they all have them integrated in their build systems. For example, Modernizer, you just say, Grunt, I want to run the unit tests, and in less than a half a second, it can run all 746 unit tests really quickly, which is nice. Bower is, if you know about NuGet or Ruby Gems or NPM, it's just a way to pull in front-end script libraries that have dependencies. So you can say, I want to install jQuery, things like that. I highly recommend you looking into that. We're not really going to talk about it much. And then the last tool is Yeoman, which allows you to scaffold your projects from scratch. And say, hey, I want a new Angular JS app, and I want this model and this controller, and you just tell them all the things that you need, and it will generate them, give you some sample tests, and just a place to start. And it will prompt you for a bunch of questions, like if you want to use Bootstrap or require JS and things like that. So in the end, we have won. So in the end, the birds win, and they're happy now, which is great. So again, thanks for attending the session. You could catch me at my blog, ElijahManor.com, on Twitter, Elijah Manor, or email me at ElijahManor@gmail.com. By the way, there were no birds injured or hurt in this presentation, so you're safe there. And if you want to find the blog series from all of these points, you could go to Manor IM ETM-Angry Birds JS.